Dear students, welcome back to online session. The topic is 0 by 1 knapsack problem using dynamic programming. Students, knapsack problem we already solved by using an algorithm design technique, that is greedy method. But again, why we are planning to solve 0 by 1 knapsack problem once again by using dynamic programming? This is the query. Now I will clarify the clear difference why knapsack problem can be solved by using two methods like greedy method. Another one is by using dynamic programming technique. So what is the drawback of finding knapsack problem using greedy strategy? And what is the main advantage or benefit of 0 by 1 knapsack problem using dynamic programming? And how to solve the knapsack problem by using dynamic programming technique, we will clearly discuss in this session. Now let us move to the first slide. Here, if you observe, the given problem is 0/1. We can term as 0 by 1 knapsack problem using dynamic programming technique. There is another knapsack problem is there, that is called 0-1 knapsack problem using 3D method. Now first we will discuss about knapsack problem with dynamic program. Students, programming means planning. The approach what we are following to solve the knapsack problem is, consider the graph here, the diagram. If you observe clearly, this is called as knapsack. Knapsack is basically means that it is a bag. It is a bag. Which type of bag? It is a empty bag. An empty bag. That means that take an empty bag. The bag capacity. The bag capacity can be mentioned with capital M. The bag capacity is mentioned with capital M. Bag capacity or knapsack capacity means maximum weight of bag. We need to fill the bag with some items. Maximum luggage or maximum weight we can able to fill the bag, that can clearly represent the capacity of the knapsack, that is represented as the M, term as M. Now, here there are some objects. There are three objects which are listed here. The first one is object one. The object one name is gold object. This is the gold item. The gold item is having profit is one. One means that 1 rupee. Assume that. Weight is 2 kg. Weight is 2 kg. Okay. So that means that if you take take the first item, this is item number 1, that is gold item. If you pick the first item, the weight of the first item is 2 kg and the profit you gain if you pick the item is 1 lakh rupees. 1 lakh rupees. Next, move to another object. This is the second object. The second object name is diamond object. The object weight is 3 kg and the profit you can earn if you pick the object is 2 lakhs. 2 lakhs. And third one is this is a red diamond or purple diamond. So this third item, if you pick, it is having the weight of 4 kg and the profit is 5 lakhs you can get. That means that in the given problem always represents there are n number of objects they will give and each object is having their own weight as well as profits are given. The main objective or problem statement of 0 by 1 knapsack problem is fill the bag. You need to fill the bag with the items, with the selected items which are available. Fill the bag. The main objective is you can gain more profit. You can gain more profit, but the bag condition is fill the bag with the items. The size of the bag or the capacity of the bag cannot be exceeded. The weight of the objects cannot be exceeded the capacity of the knapsack. Finally, you need to benefit it. So this is the main objective of 0 by 1 knapsack problem. The empty bag is to be filled with the selected items. The main objective of the 0 by 1 knapsack problem is fill the empty bag with the selected items. Condition is the total weights of items which you can fill in the bag cannot be exceeded the total capacity of the bag. Finally, you can fill the bag with the items in such a way that more profit can be earned. You can earn more profit. So this is the main objective of 0 by 1 knapsack problem. So here the profits are given in the of PI. I represents item 1, first item. P1 stands for first item profit. P2 stands for second item profit. P3 stands for third item profit. And the weights are given here, which can be mentioned with W suffix I. W1 is weight of first item, W2 is weight of second item, and W3 is weight of third item. And the main objective of the given problem is fill the knapsack with all possible items. Here there are 3 items. You need to fill the empty knapsack with possible items. But the condition is you cannot exceed the knapsack capacity. The total weight of the bag cannot exceed the knapsack capacity. And here the profits, weights, and the knapsack capacity should be positive integers, should not be negative integers. So the goal of the knapsack problem is to find the possible way in which you can maximum or maximize the total profit of the knapsack problem. Students, here you need to observe one thing. Here the given problem is 0 by 1 knapsack problem. 0 by one knapsack problem. Another knapsack problem is 0 to 1 knapsack problem. To see the difference between these two, here there is a possibility of fill the knapsack with either 0 item or 1 item, which means that you can fill the bag, you cannot select the item. 0 means you are not taken any item while filling the bag. One means that you are filling the bag with a whole item or complete item. Whole item or complete item. Here there is no fraction value. There is no fraction value. Fraction is not there. That means that fraction, no fraction. There is no fraction value. That means that the item cannot be break into some number of pieces. Okay. Here, if you observe clearly, the main difference between, there are two types of knapsack problems. One is a 0 by 1 knapsack. If it is 0 by 1 knapsack, the first point is select 0 means no item is placed in bag. Second point is select 1 means whole item is placed in bag. Complete item is placed in bag. And third one is no fraction item is selected. No fraction item is selected. So this is the way you can follow in 0 by 1 knapsack. The 0 by 1 knapsack can be solved by using the concept of dynamic programming. And another knapsack problem is that is 0 to 1 knapsack problem. That is called 0 to 1 knapsack problem. This 0 to 1 knapsack problem can be solved by using greedy method. Here, either you can take 0, 0 means full item, we can take it, or we can take one item, that means that you can take a complete item, or you can take a fraction item. Fill the bag with either 0 or 1 or fraction item. Fill the bag with 0 or 1 or fraction item. But here the item is to be break down into some number of items. The drawback is no optimal result. The result what we are getting, drawback. The drawback is, so whatever we are getting the result, that is, this is the main difference between 0 by 1 knapsack problem and 0 to 1 knapsack problem. Next we move to another slide. Here we will discuss or talk about 0 by 1 knapsack problem. The 0 by 1 knapsack problem can be solved by using the concept of dynamic programming algorithm design technique. So whereas another knapsack problem that is called as 0 to 1, that means that 0, in between 0 to 1, there is a fraction value. Either you can take 0 or 1 or fraction value. So that this 0 to 1 knapsack problem can be solved by using greedy strategy. The main difference between 0 by 1 knapsack problem and 0 to 1 knapsack problem is in a 0 by 1 knapsack problem, the items cannot be broken. That means that there is no way of provision to break the item into some number of pieces, which means that while filling the knapsack with items, when we apply dynamic programming, you need to fill the bag with the items either 0 or 1. That means that if you select 0, item is not to be taken, and if you select 1, whole item or complete item is to be selected and placed in the bag. There is no way of breaking the item into some number of pieces. That means that fractional items are not to be selected. This is the thumb rule. While solving 0 by 1 knapsack problem, always you can select either 0 or 1. There is no way of selecting fraction value. The next one is greedy approach. What is the drawback of greedy approach? The greedy approach can be used to solve 0 to 1, 0-1 knapsack problem, or greedy approach is used to solve fractional knapsack problem. So what is the main drawback of greedy approach to solve fractional knapsack problem is it cannot or does not ensure to produce an optimal solution. That means that there is no guarantee whether we are getting the correct answer or optimal solution when we apply greedy approach to solve 0 to 1 knapsack problem or fractional knapsack problem. Hence, to overcome the problem or to overcome the drawback of greedy approach, simply we can use dynamic programming technique to solve the knapsack problem. So the name of the knapsack problem is 0 by 1 knapsack problem. So students, I hope you clearly understood the basic difference between 0 by 1 knapsack problem and fractional knapsack problem. So what is the drawback of 0 by what is the drawback of 0 to 1 knapsack problem or fractional knapsack problem? So you already clearly discussed in this session. Okay. Next, we will compare the differences among the two knapsack problems, namely fractional knapsack problem and 0 to 1, 0 by 1 knapsack problem. If you observe clearly the slide, there are three differences which are clearly distinguish the difference among those listed two knapsack problems. So here, what is the difference between greedy method knapsack and dynamic programming knapsack? We will clearly observe that. So greedy method is used to solve fractional knapsack problem, whereas dynamic programming is used to solve 0 by 1 knapsack problem. So while solving knapsack problem, fractional knapsack problem by using greedy, we can follow the strategy that is the items are arranged in decreasing order of their profits by weights. Arrange the items in decreasing order of profits by weight, that is P by W ratio, and then items are selected to maximize the profit. So this is the approach we are following while solving the 0 to 1 knapsack problem or fractional knapsack problem by using greedy strategy. Whereas, if you apply dynamic programming to 0 by 1 knapsack problem while solving, you need to remember that when we apply dynamic programming, the item we need to follow here, divide and conquer, you need to apply. So every item is either completely taken or not. So here there is a provision whether you can take the complete item or you cannot take the complete item. But there is no way or no provision of selecting breaking items or pieces of items while filling the items into the knapsack. So here you can select either complete item or you cannot select the item, taken the items all at a once so that to maximize the profit and find the optimal solution. So in greedy method, for a particular problem instance, profits earned is comparatively higher. So we will get the higher profits. For a particular problem instance, profits earned may be comparatively lower when we apply dynamic programming techniques. So these are three basic differences we observed when compared knapsack problem with the greedy strategy and as well as dynamic programming strategy. Okay. So next we will see the step-by-step procedure or the process required how to solve dynamic programming. We will see in this slide. Okay. Here, if you observe clearly, P stands for profit, W stands for weight. So here I stands for items. I stands for item. I is equal to items. How many number of items, whether it is gold item, silver item, or another item. I stands for item. So initially you can select that the knapsack is empty. Initially the knapsack is empty, that means that 0 comma 0, this is P, and the second one is W, that means that W. So profit is 0 and weight is 0. That means that we are not filled the knapsack with any item, hence the bag is empty. If the bag is empty in the sense there is no item is placed in the bag and the weight of the bag is 0 and the profit you can earn is 0. So that is considered as S power 0. S power 0. Now here we will see what is S power 1. S power 1 is used whether each member is a pair or not. That means that S power 1 means that first, first item profit, first item weight. S power 2 means that first, that means that here you are selected one item. Here the S power 1 means that selected first item, selected I1, selected I1, which means that you have been selected the item. So this is P1 and W1. So that means that S power 1, that means that you can fill the knapsack with one one item, that is you can earn for the profit and weight of the item is also being filled. So next one is S power I plus 1. So this is another formula. So we need to compute S power I plus 1 by using the following formula S power I. Here this is very important formula. Why you need to consider this formula is, so how to find the value of S power I base 1. That means what, that Si base 1. Si base 1 equal to profit comma weight or profit minus selected item profit. You need to subtract comma weight minus selected item weight, you need to minus. Then you can set, you can identify that the pair which can be generated here, that pair of values are, are available in the given set of S power I. Belongs to means which can be available. That means that you will get the value of, this is one value, this is another value you will get. So this pair value you will get, once you will get the pair values, the pair values are available in s power I or not. If the pair values are available in s power I, that can be considered as belongs to. If not available, you cannot consider belongs to. You cannot consider. You cannot be considered not belongs to. Not belongs to. So s power I equal s power I base 1 equal to profit comma weight of the items, and the you can remove the profit once an item is to be filled, and you can remove the weight once an item is to be filled from the knapsack capacity, and check the pair values which you already placed, the pair values which you already placed, that is belongs to the s power I. Okay. Next one is s power I plus 1 can be used to compute by merging the pair of values s power I, s power I plus 1. So here there is a formula, s power I plus 1 equal to s power I union union s power I base 1. This is another formula. How to compute the value of s power I plus 1 equal to s power I plus 1 equal to s power I union s power I base 1. So these are the formulas or steps we need to consider before solving any, while solving any knapsack problem by using dynamic programming technique. Okay. Next, we can consider a rule. The rule is dominance rule, or another name for this dominance rule is another name for this rule is purging rule. Purging rule. So the dominance rule or purging rule we are adopting in the given problem. So that's why I have mentioned what is meant by dominance rule and what is meant by purging rule. So this dominance rule or purging rule is required to solve the knapsack problem. If you want to solve any knapsack problem, so you need to apply dominance rule or purging rule to the each and every pair of values like s power 0, s power 1, s power 2, s power 3. So you will get the pair of values. So now we need to apply the dominance rule or purging rule to those pairs. And here we can conclude that what is meant by dominance rule. What is meant by dominance rule, we will see. So dominance rule is a rule in which here consider two pairs. This is one pair and this is another pair. Observe that EJWJ stands for profit of an item J, weight of an item J, and profit of an item K, weight of an item K. Assume that these are two consecutive pairs. These are two consecutive pairs of items I and J respectively, such that they are satisfying one condition. They are satisfying the condition. The pair values are satisfying the condition, that is the J item profit is less than or equal to P item K item profit. The J item profit is less than or equal to P item profit, and the weight of J is greater than or equal to weight of K item. If the condition satisfies, then we need to remove the pair is, we need to remove. Discarded means removing. Discarded in the sense removing. Discarded in the sense removing. REMOVE, remove. Discard means remove. So here, remember that once the pair of values are generated for s power 3 or s power 2 or s power 1, we need to apply dominance rule. once dominance rule are applied to all the pair of values. So here, if any pair of values satisfy the given condition, then that pair of values need to be removed immediately. Okay, that clearly indicates that which type of pair we need to remove is clearly indicated here. So if a consecutive pair of values are available, always remember that remove the pair of values, less profit, more weight. More weight and less profit. If any pair is having more weight, less profit, that less profit, more weight paid only need to be removed. Okay. So here discarding or purging rules such as this is called as a dominance rule. So that means that the rule is called as a dominance rule or purging rule. Here, PKWK dominates PJWJ. We simply removed PJWJ pair. That's why PKWK pair is dominated. Now let us consider a simple example how dominance rule or purging rule is applied to a given problem. Okay. Consider an example. These are the sequence of pairs. Consider there are four sequence pairs 4.6, 4 comma 6, 5 comma 8, 6 comma 7, 5 comma 8. Assume that these are pairs. So here 4 is profit, 6 is weight, 5 is profit, 8 is weight, and again 6 is profit, weight is 7, and 5 is profit, 8 is 8 is weight. So these are four different pairs which can be generated for s power 2. Assume that s power 2 so is the function in which so the s power 2 contains the pairs. There are four pairs here. If you observe clearly, apply the same technique PJWJ and PKWJ. So assume that this is PJWJ, PKWK. If you assume that herely, if you consider herely, so the dominance rule is applied for these two pairs. The dominance rule is applied for these two consecutive pairs. So we simply apply dominance rule for these two pairs here. Okay. So remove, we need to apply DAS. So that means that here this is profit, this is weight, this is profit, this is weight. That means that here the profit is more and this is the weight. So if you compare these two weights, here profit is more, but here profit is less. Profit is decreasing, weight is increasing. If you clearly observe that profit is decreasing, weight is increasing. That means that while filling the knapsack with profits or weights, when this type of scenario occurs, that means that profit is less. That means that profit is less and weight is high. If profit is less, weight is high, then only you simply remove the pair. Which pair will you need to remove? Which pair is having less profit and more pair, more weight? So here 5 comma 8 is having less profit and more weight if you compare to 6 comma 7. That's why simply you can remove 5 comma 8 from the given set of pairs. From the given set of pairs, simply you can remove 5 comma 8. So this is called as dominance rule. So that means that while filling the knapsack with a pair of values like profits and weights, remember that always try to remove the pair of values when less profit, more weight, pair is identified in the given s power 1 or s power 2 or s power 3 or s power 4, in this case, always remember that the pair you need to remove is less profit or more weight pair. Always remember that, and that pair is need to be removed here. Okay. Now, friends or students, I will say the shortcut method here. There is a problem. You need to solve the given problem by using 0 by 1 knapsack by using dynamic programming approach. The problem is 0 by 1 knapsack problem. You need to solve the given problem by using dynamic programming. You will see here n is equal to 3. That means that there are three items. Item 1, I1. This is item 2, I2. This is item 3, I3. So there are three items like I1, I2, I3, which represents the first item is gold item, second item is diamond item, third item is purple item. And here M is knapsack capacity. The capacity of the knapsack is 6 kg. So you can fill the bag with maximum weight of 6 only. You cannot fill the bag with more than 6 kg. So here the profits are given. That means that the profit of first item is 1, the profit of second item is 2, the profit of third item is 5. So if you fill the bag with the first item, gold item, you will get 1 lakh rupees. If you fill the bag with the second item, diamond item, you will get 2 lakhs rupees. If you fill the bag with the third item, purple item, you will get 5 lakhs rupees. So this is the weight of first item. So if you fill the bag with gold item, it will take 2 kg weight. If you fill the bag with diamond item, it will take 3 kg weight. If you fill the bag with purple item, it will take 4 kg weight. And here the problem statement is fill the knapsack. You need to fill the knapsack, fill it just fill the knapsack with all possible items like gold item, silver item, or purple item. So before filling the knapsack with the possible or available items, you need to remember that there is a condition whether you can have the provision select 0 or 1. Either you can select 0 or 1, which means that you can fill the bag with complete item or you cannot select any item. There is no way or provision to fill the knapsack with the items in a piece of items or break the item into some number of pieces. That means that fraction items are not to be filled in this bag. You have the provision. Either if you want to place an item, you can place the complete item or not to place the item. There is no way or provision to fill the knapsack with fraction item or break the item into some number of pieces. So this is the condition in 0 or knapsack means 0 means no item is selected, 1 means complete item is to be selected. So weights are given, profits are given, knapsack capacity is given, and number of objects are given. So the main objective or the main function or the main problem statement of 0 by 1 knapsack is fill the knapsack with with the available products by satisfying the condition, the total weight of the total weights of all possible items. You need to fill the items here. The total weight cannot be exceed knapsack capacity. The total weight of all items cannot be exceed knapsack capacity. Wi less than or equal to m. That means that total weights of objects which you can fill in the knapsack that cannot be exceed the knapsack capacity. Either it is equal or less than to the knapsack capacity. The total weight of the objects are equal to the knapsack capacity or less than to the knapsack capacity, not more than knapsack capacity. And finally, you need to get more profitable. Always try to get more profit only. Try to get more profit only. So you will get the more profit. So this is the condition. Fill the knapsack with complete item or not selected item, not selected item or complete item. Fill the bag by satisfy the condition is Wi less than or equal to Mi to maximize the profit. So this is the main idea, or this is the main problem statement or objective of 0 by 1 knapsack problem. The problem can be solved by using dynamic programming. Here, the values of M profits weights are positive integers, not negative integers. Okay. So here, so you can select this one first. How to get the how to fill the bag. So you have the provision to fill the bag maximum ways. This is the first item. This is the second item, and this is the third item. So there is a provision of filling the knapsack with three possibilities: first possibility, second possibility, and third possibility. And on which possibility, on which way we can fill the bag, we will see here. Suppose if I can fill the bag with, suppose x1. This is first item is x1. Second item is to be not selected, and third item is selected. Okay, assume that. Just assume that. So here this is free. That means that I am not taking any item here. That means that if I can take x1 item, x3 item, that means that this is 1, this is 1, second item is 0. Why? Because I was not taken second item. So in this case, so what is the weight of x1? Weight of x1 is 2 kg plus weight of x3 is equal to 4 kg. So 2 kg plus 4 kg equal to 6 kg. So 6 kg is less than or equal to m. So the weight is less than or equal to m1. So this is possible. If I can fill the knapsack with complete item of x1 item and complete item of third item, and I was not selected second item, so if I can follow this strategy, so what is the profit I can get? I can get the profit is 1 plus 5, 6 I can get the profit. So I can get the profit is 6. So profit of first item plus profit of second item, profit of third item. Suppose assume that if I can select the items is first item is x1 and the second item is x2 and I was not taken third item. I was not taken third item. If this is the case, so what is the maximum weight? X1 item is fully taken, that is weight is 2. X2 item is completely taken, that is weight is 3. And total weight is 5. I was not taken third item. So the total weight of first item plus second item is 2 plus 3, 5. 5 is less than or equal to M6. The condition is true. So here, what is the profit I can get? If I can fill the bag with the first item and second item, then I can get the profit is first item profit is 1, second item profit is 2. 2 plus 1, 3. So I will get the profit is 3. If I can fill the bag with first item x1, comma, second item x2, comma, third item x3. In this case, that means that if I want to fill the bag with all three items, what will happen is, so if I can fill the bag with x1, the weight is 2. Again, I can fill the second item also. The total weight is 3 plus 2, 5. Then how many weights are left? Only 1 kg is left. Why? Because when you fill the bag with x1 and x2 item, the bag occupied 2 plus 3, 5 kgs, and only 1 kg is left. If you want to fill the bag with third item also, you cannot be placing third item. Why? Because why you cannot place third item B means if you place third item also, the bag capacity is exceeded. 2 plus 3 plus 4, 4 plus 3, 7 plus 2, 9. So 9 is less than or equal to M. The condition is false. The condition is false. To overcome the problem, simply uh, you can have the choice is either you cannot select the item or you can select the item, but in this case you cannot select the item, so only you can select item 1 and item 2. If you select item 1 and item 2, you will get the profit of 3. Okay, and one more option we will see. First item not selected, that is 0. Second item I have been selected, complete item x2 I have taken. Third item I have selected, complete item I have been selected. So in this case, what is the weight? If the first item I have not taken, 0 weight. Second item I have selected, weight is 3 and weight is 4. 4 plus 3, total weight is 4 plus, sorry, 3. 4 plus 3, 7. Total weight is 7. 7 is not less than or equal to 6. The condition is false. So this is also not possible to fill the knapsack. In this way also, we cannot fill the knapsack also. And in this way, finally, I can conclude that, finally, what we can conclude that, so there are many ways we can fill the bag. So if you fill the bag with x1, x2, x3 in such a way that the set of values is 1, 0, 1. This is the answer. If you fill the bag with 101, that means that first item is fully selected, second item not selected, third item fully selected. Third item is fully selected. 0 means item not selected, second item is not selected. 1 means fully item is selected. Complete item of x1, complete item of x2 taken, and item of second item is not selected. If you select the items in such a way, while filling the knapsack, the total capacity is 6 and the total weight is 6. 6 is less than or equal to 6, condition satisfied. So this is the way you can move it, but the profit you can gain is, you will get the profit is x1 plus x3, x1 plus x3, 1 plus 5, you will get the profit of 6 only. You will get the profit of 6 only. That means that sum of pi xi you need to calculate. Sum of pi xi you need to calculate. That means that p1 x1 plus p2 x2 plus p3 x3, you will get the value of 6. So the customer will be benefited while filling the knapsack with the way of x1 item completely selected, x3 item completely selected, and x2 item is not to be selected in such a way that so he can be able to gain more profit by satisfying the condition. So the best real-time example for 0 by 1 abstract problem is rope a story. If you want, if a thief planning to rob a ATM machine, a thief planning to rob an ATM machine or banking sector, he can be able to identify some number of gold items, some number of uh, diamond items and some number of um, double items, and he has to carry an empty bag with him. And why? Because why he has to carry an empty bag with him is his objective is the main objective of thief is he has to be benefited. Finally, he has to be benefited. How the thief will be benefited? The thief will be benefited if he can get or earn more profit, then only the thief will be benefited. But here the condition is he has the provision to fill the bag with maximum filling the items of not more than 6 kgs, not more than 6 kgs. And he has some constraints also. The constraints are whether he can fill the bag with a complete item or he cannot select an item at a time. He doesn't have any provision to fill the bag with fractional items or breaking the item into some number of pieces. If in this way we can follow, we will get the optimal solution. Hence, finally we can conclude that if you apply dynamic programming technique to the 0 by 1 knapsack problem, so you can ensure that you will get the optimal solution. So there is a drawback of applying knapsack problem to there is a drawback of knapsack problem, that is greedy strategy. When you apply greedy strategy to the knapsack problem, so ensure that there is no possibility of getting optimal solution. That means that whether you are getting optimal result or not, there is no guarantee. That's why. So hence we are better go for considering dynamic programming approach while solving knapsack problem. Students, so this problem I have solved orally, so with my knowledge in a shortcut way. So I will clearly explain the step-by-step procedure by using the formulas, how to solve 0 by 1 knapsack problem by using dynamic programming. I will clearly explain in next class. Hope you all are doing well. Thank you. Thank you.